first record. Yeah, okay. This week, I will tell you first the plan that on Friday we will do the quiz, the last major quiz in this semester. And the material will be up until Wednesday. So on this day, tomorrow and Wednesday, you will have new materials. It's relatively small, not that big. So let's just start with this new thing, imaginary numbers. For imaginary numbers, okay. If you still have your notes about the last practice, okay, this one, number 4. Before I go to the imaginary numbers, I have told you that I will explain about proving that the x1 plus x2 equals negative b over a, and x1 times x2 equals c over a. So let's see number 4 first. Okay, number 4, after you try to do the quadratic formula, the x1 is negative 2 plus square root of 60, I think, yes, over, I haven't simplified, okay? Square root of 60 over 4. So x2 will be equals to negative 2 minus, if I simplify it, it becomes 2 square root of 15 over 4, okay? So now let's start by adding, okay? If I add this, I will have negative 2 plus, let's just say 2 square root of 15 over 4 plus negative 2 minus 2 square root of 15 over 4. If I have addition of fraction and the denominator is already the same, so I can just directly combine all the numerator, right? It's just the arithmetic things. So over 4. So negative 2 minus 2 is negative 4. Let me go here. And this one plus 2 square root of 15 minus 2 square root of 15. It becomes 0. So in the end is negative 4 over 4 equals negative 1. If I use the formula, x1 plus x2 equals negative b over a. The b is 2, the a is 2. So negative 2 over 2. Yes, it is negative 1. So we have proven that the formula is reliable. Okay, so how about if we multiply it? Multiply it is kind of, actually it's just the same, but it tends to, yeah, we need more space on that. So if I multiply it, let me just, if I multiply x1 times x2, it becomes, wait, back then, negative 2 plus 2 square root of 15 over 4, I think that's right, multiplied by negative 2 minus 2 square root of 15 over 4. Multiplication. Okay, it means that this will be the numerator, and then the denominator becomes 16. So far, any question? If you multiply the first one and the second one, okay? So how we multiply the numerator? Again, we just find this situation as like this one, right? Okay, so if you don't like to use that, you can use the box thing, right? If I use the box thing and I use different color here, the box thing here, and then I have, this is negative 2, this is plus 2 square root of 15, this is negative 2, this is negative 2 square root of 15. When I multiply negative 2 times negative 2, I have 4. This one is negative 4 square root of 15. This is 4 square root of 15. This is negative 4 times 15 equals negative 60. So in the end, that I will have the numerator is 4 minus this plus this, it is 0 minus 60 over 16. So it is equals negative 56 over 16. Okay, equals negative, what's this? 14 over 4, negative 7 over 2.
2.5.
Yeah, so by calculation manually, we find that the multiplication or the product of both roots will be negative 7 over 2. But if we refer to the formula, if we multiply x1 times x2, just take the c and a. The c is negative 7, the a is 2. Therefore, it is negative 7 over 2. Done. So again, you need to know what's the formula is looking for. Okay, in case that you need to find it quickly, just use the formula. In case you want to, yeah, there's many purpose on it. So let's, any questions so far?
Mister, so for these type of formulas, like in what type of questions will it be used, like for the x1 plus x2 and yeah.
Only if you have to find the product or the sum of the roots only. So actually in graphing, in many problems of quadratic, we tend not using it, but later on 11th grade and 12th grade, later you will find it useful. So it's only if you are asked to multiply x1 times x2, or if you need to find the sum. That's all. Yeah, thank you for asking that. Actually, it's still not relevant for this, especially for the real world problem that you will face later. We still haven't used this one, but I just want you to know the correlation between x1 and x2. Okay. Any other question? So actually, still this is still the addition for previous material. If you have no question, since you need to be prepared, to prove. Okay, just don't let it pass. I know that maybe you say that the most important thing is the product and the sum, but you need to master when you are asked to prove the addition or the sum or the product is this, you need to do as just like I have already shown you before. Okay, that's the thing. So now, how about this one? Okay, now this is the material for today. If you want to find the discriminant, just to check what kind of case that you have. The discriminant, don't forget, it is b squared minus 4ac. So it is equals to negative 10 squared minus 4 times 3 times 10. So it is 100 minus 120. It is negative 20. My question is, Justin Nathan, what case that we have now? If the discriminant is negative 20, what?
Oh, it will be irrational because it's not perfect square and imaginary.
Irrational and imaginary cannot combine there, since irrational are real numbers. Imaginary is not real numbers. So what? So you need to choose one.
Irrational and real.
Because of the perfect square. It's not a perfect square. How about the negative one?
Negative is not a perfect square and it cannot be square root.
Yes.
So it's imaginary.
It is imaginary, not irrational. Okay, imaginary numbers.
Oh.
Imaginary numbers. And there are two different values. Okay, so I hope that you're clear now. So previously, you can answer it that there is no x-interception here. Okay, but for now, I don't want you to go to that way. Okay, just answer it. Yes, thank you. Imaginary cannot be rational. So imaginary numbers, two values. Therefore, starting from today, you cannot say that, Mr. The answer is no x-intercept. This is not acceptable. You have to go further. Okay, so yeah, how? It's okay, it's okay. So how do we go further? So let me just clear it. And I know that the d equals -20. So just use the quadratic formula, right? If I use the quadratic formula, let me just combine it. X1, X2 equals -b plus minus square root of d over 2a, right? So it is equals 10 plus minus square root of -20 over over 6. So you need to present this. So the x1 will be equals to 10 plus square root of -20 over 6. And the x2 will be 10 minus square root of -20 over 6. Okay, so that is your answers. But this is not the final yet. Okay, the thing that I want to introduce you, and maybe some of you have already known this, negative square root of -1, it is equals to I, okay, lowercase. So if I try to separate this, this is 10 plus square root of -20 is square root of 4, oh no, sorry, square root of 2 times 2 times 5 times -1, right, over 6. Okay, therefore, let me just clear the one at this part. Let me show you how to simplify this. So it is equals to 10 plus 2 square root of 5 square root of -1 over 6. Keep in mind in radicals, square root of 3 times 7, it is equals to square root of 3 multiplied by square root of 7. So for square root, you can separate it as long as it is multiplication. This one also, square root of 2 times square root of 2 times square root of 5 times square root of -1. Since square root of 2 times square root of 2 is 2, so you just leave it 2. Square root of 5 and square root of -1. Square root of -1 is I. So the statement will be 10 plus 2 square root of 5 I over 6. Any questions so far? So the final answer, you cannot present only in negative radicals, negative radicand. This one, it's not the last answer yet. You need to simplify it until there is an I there. This one. Okay. Has,
Mister,
yeah,
for that one, the last one, 10 plus 2 squared of 5i per 6, can it be simplified again
yes,
into dibagi lagi dua-dua gitu?
betul, betul. Itu belum selesai kok.
The I,
Thank you.
how about the I? The I part.
So actually, the how you play this to cancel it, actually you extract 2 from the numerator. So let me put into this left one. So 2 multiplied by 5, wait, plus square root of 5i. Can you understand that part? So I factor 2 from the numerator over 6. So I cancel this one and this one, it's 3, right? Therefore, the simplified one is 5 plus square root of 5i over 3. That's the final answer. for your x1. Your x2 will follow. It's just 5 minus square root of 5i over 3. This is your second x. See, the difference is only between the addition and subtraction, right? So I want you to read the textbook, but you need to be familiar with the conjugate. Conjugate. So x2 is the conjugate of x1. Vice versa. x1 is the conjugate of x2. Okay, the conjugate always, the difference always in the middle operation, addition and subtraction. But you can learn more from the textbook. So far, any question? Actually, this is just the only materials that we want to learn, but the application is quite complicated. So let me write down the conclusion. Only two conclusion. First, square root of -1 equals I. Therefore, I equals square root of -1, right? Okay. Reflexive or symmetric axiom. And then this is the first. The second, I square will be equal to Tiffany. Can you answer this?
Square root of -1 squared.
Which is, can you simplify?
Square root of -1.
Square root of -1 square. So how do you simplify it? The square is outside, of course, right? So yeah, like that, right? This is I, and then this is square. So what is the result of that?
-1.
Yeah, good. -1. So I want you to be aware. So only these two statements. I equals square root of -1. Therefore, I square also is, I square is -1. Okay, these two things, and I want us to deal with some problems with this new thing. Any questions up until now? I hope it's clear. So again, if you have the discriminant equal or less than 0, I want from now on, you find the values in I term, okay? So yeah. Wait, let me, so some of you may ask, Mr. Actually, what's the point? Actually, when I graph it, it's clearly there is no x-intercept, right? There is no x-intercept since there is no real values. Why should we learn the values of the imaginary numbers? Since imaginary numbers is not being fair that we call it imaginary. That's why some of you are tricked with this. Imaginary doesn't mean that we imagine the numbers. No, it exists. It exists. That's why nowadays the mathematicians try to propose to change the name, not imaginary, more than lateral. Since we tend to be tricked by this. So actually it exists. How? In another dimension. How do we depict this? That's why I share you the YouTube. It's hard for me to graph it, but the YouTube is very well describing what is the imaginary looks like. So the parabola exists, and when you see the Cartesian axis, there is no x-interception, yes, but when we extend to another dimension, actually there is an intersection. But it's it's hard for me to describe it. So that's why if you are curious about how it works, these imaginary numbers, just see the YouTube. But in the end, you need to find the values in imaginary numbers. Why? Because they exist. So the x-intercept exists. for the discriminant is less than 0, it still exists. They are still exist. Okay, so I want you to be clear about that. Therefore, you don't have to say that this is nonsense, right? Of course not. Okay, now let's practice. Let's simplify this. I want you to do it quickly, and then maybe I will ask some of you. Only 4 numbers, 4 radicals. I want you to simplify. It means it has to be the simplified one with I. The statement is with I. So yeah. I think while you are doing it, let me ask from number 1, Valencia. What is the number 1 answer?
I square root of 3.
Okay.
Okay.
Just make, okay, thank you.
Thank you.
Just make a habit that the I you put at the at the back. So thank you. This is actually correct, but let's just use this. Yeah, simple, right? Square root of -3 is square root of 3 multiplied by square root of -1. So it is square root of 3i. And make sure the I is outside the square root. So do not write it this way. Okay, this is totally different. Okay, so the square root, the vinculum must stop here. Okay, so yeah, if you prefer to do this, just to clarify that it is outside, it's okay. It's okay, but usually we use the I at the back. So next, Cliff, what is your answer, Cliff? Number 2.
3i.
Yes, thank you. Okay, Jason, number 3.
Square root of 61i.
Good, simple so far, right? Now this one is number 4. Yeah, it's there. Who wants to try this one?
May I try?
Please, please.
6 square root of 2i. I guess.
Excuse me. 6 square root of 2i. Good, thank you. So how do you do this? Actually, just use the factor. So actually, this is 2 times 2 times 3 times 3 times, wait, salah. 2 times 2 times 2 times 3 times 3, I guess. Yeah. And then times -1. Don't forget about that, right? So actually you can, this one, you can send it out. This one, you can send it out also. So it is 2 times 3 times square root of 2 times square root of -1. In the end, it is 6 square root of 2i. Yeah. Okay, that's how you do it. So actually, the simplification is the same with the radicals before. You just put the I as the addition. Therefore, so far, any question? No, we're good. I hope we're good. So this is the last thing that I want to teach you before we go, before I dismiss you. So, okay, for your homework, you will find the x-intercepts or the values of x that they are all in imaginary numbers. Not all, actually. Some of them are imaginary numbers. Okay. And then you need to check. Okay. Okay, so yeah, that's the thing. So x1 for this part, if I'm not correctly remembered, it is, wait, 5 maybe, plus square root of 5i, right, over 3, I think. I think that's the last answer for
Yeah.
number 5.
Yeah,
Oh,
it is.
thank you. Thank you. So after you find this, okay, out of your curiosity, the book asks you to check. Just be skeptical. Okay, check whether one of the solution, just one. Okay, just one. So that's the good news. You don't have to check both, just one. Put into the equation whether the y equals 0, since this is the x-intercept. So let me show you how. So actually I have to prove that 0 is equals to 3. Let me use the first one, plus square root of 5i over 3 square minus 10, 5 plus square root of 5i over 3 plus 10. Okay, that's, I just want to help you about the homework. So you just need to find whether the right member is equal 0 also. Okay, so let me do it on the right side. So 0 equals 3. Don't forget, when you square this, it will be 25 plus 10 square root of 5i. Ooh, okay, plus 5i squared over 9. Can you feel the complexity here now? Okay, so minus 50 minus 10 square root of 5i over 3 plus 10. So gladly we can cancel this one and this one. Okay, so 0 equals to, don't forget, I square. Can you remember what is I square? I square is negative 1. Okay, so it is 25 plus 10 square root of 5i minus 5 over 3 minus 50 minus 10 square root of 5i over 3 plus, let me just put it into fraction. So look at the numerator. Look at the numerator. Actually, in the end, this 10 square root of 5i will be, wait. This is not right. Do I do something wrong? Okay, wait. It seems there is something wrong here. Let's check. 5 square root. Oh, why do I use this? Okay, actually I use plus, not subtraction. So yeah, it doesn't, suddenly it becomes negative 10. Yeah, so, oh, it becomes plus. Okay, wait. I should fix this. So actually it is plus. Okay, good. So because the negative 10, I have already distributed to this, therefore it becomes negative 50 here and negative 10 square root of 5i. But this one has been converted into addition. Any questions so far? I hope.
Mister,
Yeah.
for the one on the bottom, the 25 plus 10 square root of 5i minus 5, isn't there supposed to be an I on like the minus 5i? If there
No.
isn't, like where does the I go?
No, since the I square is equals to negative 1. Don't forget that. I square equals to negative 1, exactly negative 1. So
Oh,
I
so
convert.
you You multiply it.
Yeah, it becomes -5. Okay, so it is plus, this is minus minus. So in the end, you'll get the feeling that since all of this is 3, I will just solve it quickly. So it is done, it is eliminated, right? And then 25 minus 5, it is 20. 20 plus 30 is 50. 50 minus 50 is 0. 0 over 3. So in the end, it is 0 equals to 0. The thing that I want you to practice is how do you deal with squaring this actually. So yes, in the end, you will know that, we know that it will be 0 equals 0, right? But the skills that I want you to practice is to applicate the I square. Since when we square this, when we square, let me change it into the chocolate one. If we square this one, when we square this, you will have this, right? And you will have I square. And I want you to practice that. The difference between I and I square. I square you can convert into -1. But I, you just leave it be. Since I just equals to square root of -1, just leave it be. You don't have to do anything with I. Okay? Any questions? So yeah, that is your homework. I have already given you. So you're not just finding the x1 and x2 into the simplified form. Don't forget, into the simplified form. Okay? You need to check at least one of the solution. And it goes for 3 numbers, that part. The last part, so I give for this section only for, wait, let me check. I hope that I am not mistakenly say that. For this section, actually, I just give you 4 problems. Yeah, I hope that with 4 problems, 3 of it is just finding the x-intercept and then check. There are 3 of it. So the last one is just graphing an imaginary number. Mr. Martin won't teach you that. You just need to read it from the textbook, and it's very simple. You will just say hallelujah if it comes into your final exam or into your quiz. It's very, very simple. Okay, so I want you to just read it from the textbook. The graph is not that complicated. It's very simple. Okay, so only 1 number for graphing, 3 numbers. I hope that you can learn. If you cannot find it equals 0 equals 0, fine. Where is the mistakes? I want you to practice to square it and multiply it. Okay, I want to practice the arithmetic here. Okay, so yeah, if you have no more question, we're done. Tomorrow, I will provide a video. So tomorrow we will have no meeting, I think. If you okay, so yeah, tomorrow we don't have any meetings, and I have already opened the homework. So I will let you know. I have already opened the homework for today and for tomorrow, because tomorrow's material actually is not that hard. If you want to do it everything today, it's up to you. But if you want to wait for tomorrow until I explain things and then you just do it, it's fine. Okay, the due date for this both, you need to combine this both, is on Thursday morning. Okay, I hope you get it. Okay, so thank you, Tansy. You can be dismissed.
Thank you, Master.
Thank you, Mr.
God bless you.
Welcome. God bless you.